Next is Maxim.
Thank you for having me at this conference. If you can share my screen, I will be able to start my talk. Thank you. So my talk is about Fable.Form and how we can unlock your form superpowers. And I will give you a quick introduction about myself, just so you know who I am and why I'm giving a talk here. I work as a freelance right now, and I have a strong focus on developer experience. And this is shown by all the contribution I can do on open source, on Fable and F#. I am the maintainer of dot.json, which helps you work with JSON in a better way than just using untyped decoding and encoding in general. On Elmish, I maintain the hot module replacement tool, which allow you to not reload your tab all the time. And on Ionide, I worked on the syntax inlighting and tooltips and doc formatters. So all that is focused on developer experience. And the next problem that I wanted to solve was a forms problem, which is something that I tried to solve for several years now. And to give it a start to this talk, I'm going to tell you a small story. So once upon a time, at the beginning, there was HTML. HTML is just simple syntax, so that's great, but it's not typed. You work with strings everywhere, and you can make typo a lot. You don't have a lot of interactivity out of the box. For example, you cannot make steps easily. You need to add additional libraries, and if you try to do everything by hand using JavaScript, it's really difficult to do. Another problem that you have with HTML is you don't have function or templates out of the box. So you will need to duplicate your code in every different places of your application. And if you change your CSS classes, you need to change them at every places. So it's difficult to work with at this point. Then we got Elmish in the Fable world, which brought us some light. Elmish was a really great addition to this problem, because now you can have all the interactivity you want because you have access or full control over what you do, and it helps you maintain your states. However, one problem that you can have with Elmish is that you need one message per field. So here, for example, you have an unchanged email of type string, which handles the email fields. But if you have 10 fields, you will need 10 messages to do it. And 10 message means more boilerplates, because in your update function, you then need to handle each of these messages and decide how you want to handle them. Do you want to handle the validation during each keystroke, or when the user leaves the field, or on submit only? And the other problem that you can face is your view can become quite complex, because you have no structure on how your code should look like when dealing with forms. So you will have to write your own kind of form libraries, which is difficult to do right. 4 years ago, I gave another talk about forms at a Fable.Conf, and this talk was about dot.Elmish form builder, which gave us a ray of hope in this form problem. The main benefit that dot.Elmish form builder gave us was the idea that you don't need to consider each field independently, but you can try to see your form as a whole or as a singular structure, which means that you can have only one message to enter your form change state. And this gives you the ability to scale with as many fields as you want. The other addition that dot.Elmish form builder gave us was the fact that you can kind of define your forms outside of your view. And this is what we see at the bottom here. So we create a form which is going to use the onForm message, and to add a field which calls the add field function, to which we provide some field information. Like here, we create a basic input with an ID name and a label name. We make this field required, and it uses a default view rendering system. If I have to add another field to this form, I can just do the same stuff, add field and basic input or select or basic select, and fulfill some contracts with the Fluent syntax. This means that in the init and update function, I don't have a lot of boilerplate anymore, and for the rendering function, I just call form.render with a few configuration objects, and that's it. This was a great improvement, but there is some drawbacks to Elmish Form Builder. The first one is it has limited interactivity. You cannot do steps. You cannot compose forms with another form, so you cannot reuse the forms easily. And also, it's using a lot of magic strings under the hood. So, for example, the basic input here is only identified using a basic dash input string, which if another library provides the same ID or identifier for this type of fields, is going to create conflicts in your code. So after this situation, what's happening is nowadays we have Fable.Form, which is a new superhero, and I'm going to try to showcase you why I consider it the new superhero and what is so powerful about Fable.Form. So I'm going to jump into the code and show you how form can be set up using Fable.Form. The first things that we need to do using Fable.Form is define a value object, which is going to store the view representation of the state of the form. So we are going to have an email field, which is a style string because this is an input. And we wrap it inside of the form view model provided by Fable.Form, and we use it. We use this type as a model of our Elmish application. From here, we have the same idea that .elmish form builder gave us, which is we only need one message to handle the form change, which is here from change of model. And we also have another message to handle the submit case. So when I get by the login message, it means that the form has been submitted and I will get the result of the form here. We can initialize the Elmish function, so the init function and the update function. Nothing really interesting happening here. And below, we are going to be able to define how our form is going to behave. So what we do is we create an email field value, and we define it as a text field, which is going to accept any type of input. We are going to come back to the parser later. We teach it how to access the view, the current value that the input should have, so email in this case, and how to update it. We don't handle any external errors for now, and we provide some attributes to the field, which are specific to the fact that this field is actually an input box, so it can have a label, a placeholder, and some HTML attributes to provide autocomplete, for example. Then we wire everything together by saying that when the form is submitted, we create a login message and we append the email field to our form. Once this is done, in the view, we can just call form.view as HTML, provide a few information like the dispatch function and which message is used to handle the form change, the model, the form definition, and the current state of the view, and that's all there is that we need to set up to get the form. So now, if I go to the browser, we can see that I have an email input field, and I can pass in any type of string that I want, and I can click on submit, and it says that I have been logged in successfully. Problem with that is I can pass it anything that I want, so even an invalid email address. A big improvement that Fable.Form has compared to .elmish form builder is the fact that we can make a distinction between the state of the view and the actual output that we want from our form. So for example, as the output of the form, I don't want a string. What I would like to have is an email address type. If we go into email address definition, it's basically a private type, so I cannot create it outside of this module. And the only way I can create it is by using this try-pass function, which is going to make sure that my email address has at least a NAT symbol. Otherwise, it's going to return an error. Obviously, this is still not perfect to validate an email, but it will do good enough for the demo. So now that I said that the output of my form should be an email address type, I can follow the compiler's errors, which is telling me that it was expecting an email address as an output, but it got a string. The way to fix that is we can provide here to the parser property the try-pass function coming from the email address module. And if I save again and go back to the browser, so now if I try to enter test and sign in, it's going to tell me that the email address is invalid because I need the @ symbol in it. So now I can type an email address and try to submit again. So here we saw the difference between the view state representation and the output of the form, but right now we have a form of only one input. What does it look like to have another input to our forms? We are going to do just that now. So in the view representation of the form, we are going to add a password field of type string because this is a view, and inside of the view we manipulate a string. But as an output of the form, what I would like to have is actually a user password .key, which is the same thing as we did with email address, but just for the password. And in the init function, we initialize the initial value of password to an empty string. We need to fix this pattern match to accept a tuple now. And inside of our forms, we are going to need to create the password field. So here I can create my password field, and it will be a password using form.password field. So there is stars or the password is not displayed in the view. Then we are going to pass it the parser. Compiler is providing everything for me. So we provided the parser here to get back the password type. We teach it how to access the password values. We don't have any external errors, and we provide just the password label, for example. Something that we are going to change here we are going to create a non-submit function because now I need to create a tuple outside coming from a function. So here I'm going to accept a password, an email and a password values, and create the login message that we get as an output of the form. And I'm going to pass it here instead of passing directly login. And I'm going to append a new field to the form. If I click save and go back to the browser, now I can see that I have a form with two fields, and I can provide some information into the first one, try to submit the form, but this field is required. And if I start to type, you can see it's telling me that the password must have at least 4 characters, and I cannot submit the form unless I fulfill this need. Now that I have at least 4 characters, I can submit the form as wanted. Just going to try to disable. No, don't know how to do it. So now that we have some forms with multiple fields, that's all nice and good, but it seems like we did a lot of work to configure it, and it's not yet so powerful. What if we were able to compose forms using other forms that we defined? This is something that we are going to try. If we look at the pipeline definition of these 3 lines, what we can see is that every time the type of each line is actually a form. So even a single field is a form. So what happens if I have a form with multiple fields already underneath it? This is what we are going to try. And I already prepare an address form which is a form which will work by creating a field of type country, city, and postal code field. And this form, now that it has been created inside of Fable.Form or inside of my application, what I can do is I can reuse this same form inside of other forms from my application. So it means that if I can use it for the creation of a user, for the page where the user chooses a delivery address, and so on. And every time I'm going to change this form, it will be reflected at every other places that I called it. So we are going to add it to our form in the demo. We follow the same principle as before. We need to store the view representation of the form, which is going to be form address form dot values, because this is a record provided to us by the address form module. We need to initialize it using the address form dot blank. And we also need to change the output of the form to give us an address of type T, which is a strongly typed address now. We need to add address argument inside of this function on pattern match. And now we need to go on the submit function and add address. And we just add it to the tuple. Now I need to embed the new forms inside of it, and it's a bit more, or it requires a bit wiring compared to the previous one, because previously we were using the property as there was. Now we need to map the values between the current form representation into what address form is using internally. The way to do it is we append a new form, but instead of calling directly the new form or the field, what we are going to do is we are going to map the values and teach it how to access the address value and how to update it. And then we are going to pass the address form that was defined inside of the address form module. Now I can save my form and go back to my browser, and we can see that the forms now got 3 more fields, which I don't know about. I don't know how they work, but they are still provided to me, and because I fulfill the contract, they are here. And so I have the country, city, and postal code field. That's all nice, but I would like to encapsulate them inside of a section. And forms can also not only give you interactivity, but also some visual indication or control the visual look and feel of your application or your form. So you can do, for example, a form.section, which is going to ask me for a string, which is the name of the section. And inside of it, I'm going to provide the same form that we used before and save. And now I can go back to my form, and you can see that I have a nice section called address, which wrap my form address. This example was just to show that inside of Fable.Form, you don't only have field or specific forms that can add functionality, but it can also impact the visual representation. So if you have a form.horizontal, it can probably group your fields horizontally, and so on. To summarize this demo, I just took a screenshot of what is on the index page of Fable.Form, and we can check if we check each of this mark. So we saw that the form was composable because we were able to reuse other forms. For example, the form address was reused and embedded into a form. It's type safe because the F# compiler is tying everything together for us. And the really nice feature is we have a clean distinction between what's type used for the view and what are the type of the output used by the form. It's scalable, as I don't need one message per field, but I just need to describe the form logic. and all the form logic is defined in a single place, I can just follow my form.append function and see what type of field is being appended to my form. This was for the tierce checkmark. And modular, we are now going to have a quick tour on how Fable.Form works, because in a 30-minute talk, I can't show you how it works using the code. So I'm just using schema now to explain how it's used and why it is modular, and you can use it to fulfill your specific needs. Fable.Form use a layer structure. It's used three layers, which is the core, the logic, and view, and on top of it, you have your application, which is the code that you are responsible for. The first layer, core, is handled by the package Fable.Form, and what it does is it provides a common set of types and functions to manipulate forms. And for example, you define the forms of these specific types, and you can just read it as if it was a function taking some values and returning you an output. And here is how it's defined a field, which is a value with an update function, so it knows how to update its state, and some attribute attached to it, like the label or placeholder informations. On top of this core layer, you then have the logic layer, which is handled by Fable.Form simple in this case. And what your logic layer does is it defines all the type of fields that your application can support. So in this case, text, radio, checkbox, and select, and also some non-standard fields like group, section, and list. And as you saw earlier, section is just a way to change the visual representation of your form, but it doesn't add any functionality to it, we could say. It's also responsible for defining all the contracts that you use for your fields. So here we have the different modules for representing your text field or select field. And you can see what the attributes types that I keep talking about are. For our text field, this is a label, placeholder, and some HTML attributes. But in the case of a select field, what you have is a list of options, for example, so you can have the different options that your user can choose from. The last layer is the view layer. The view layer is handled by Fable.Form simple Bulma in this case. And what it does is it takes all the type defined in your logic layer and transforms them into HTML. Here is the code for the input field, where based on the type of fields that we want to render, we choose the input function that we are going to use to render it, either text or password. And we wire everything together, like the onChange event, the onBlur event for validation. Is my field disabled, or should I show the field with some errors, and so on. Because it can be a bit complex to get started with Fable.Form and understand what you need to use it inside of your application. And I hope you will give it a try after this talk. There is also this schema on the Fable.Form documentation, which try to help you understand which package is the right one for you to base your application on. So if you use Fable.Form, if Fable.Form simple support all the fields that you need, and that you are using Bulma, for example, you are going to need to use Fable.Form simple Bulma, and you are just ready to go, nothing to implement on your side. But if you need some specialized field like color picker, date time picker, and so on, you will need to use the core package as the building blocks of your application and implement your own form and view logic. It can be a bit intimidated at first to implement these low-level packages, but you can just copy-paste my code and try to play with it and just follow the compiler's errors. And in general, it's pretty easy to do it once you did it once. Oh, that was all for Fable.Forms, but I would like to give a quick tour to what we can do above Fable.Form. I have 5 minutes left, so I'll try to be quick. And what we can do is go infinity and beyond. And I'm going to use the case of one of my clients. One of my clients asked me the question, or in their application, they had the problem that forms can be defined by users and not by themselves. So it means that they don't want to deploy a new application every time there is a new form. And they asked me the question, is it possible to have serializable form? And I say, perhaps, because everything that Fable.Form use is function and there is no magic in it. So if I can wire the function myself as a human, I can probably fulfill a contract between a domain and a mapper to transform this domain into Fable.Form functions. The way we do it is we once again handle the view representation state. So in this case, we have some input which manipulates strings, checkbox a boolean, and yes, no field, which is a specialized field which work with strings. Then we have some field definition. I'm going to pass it just for the time. And we do the form definition. So the contract is that a form is a list of steps, where the step is actually a list of fields, which we can see above. I'm going to, and the next step is to say that I have, for the domain, I have a JSON in this case, but we could use any serializable format. And what you want to do is take the JSON, map it to Fable.Form, and then let Fable.Form handle the form for you. So I have a demo ready for that, just to showcase it. And if I go to my browser now, what we can see is we have a JSON with some steps, some fields too. And if I remove this, well, I need to unzoom a bit. This line of JSON, and I load the form again, you can see that I only have one field inside of this form. But if I re-add the field, I can load the JSON again, and now the form has two fields in it. And I can enter my name and my last name. So I can move to the next step, answer the question, and submit the form, and the form has been submitted, and I get better result in the console, for example. That's all nice. But the problem with this approach right now is we are using JSON, and we can't really expect a customer to write JSON. Even us as a developer, it's pretty difficult to do because we can forget a comma. We need to generate some grid information, which is not really easy to do in a human way. So the solution for that is to say, what if we were having a form designer? And the idea is, why can't we use Fable.Form to create the form designer that we need? The answer is no reason, so we can do it. So here, for example, on the left, I have a form designer. On the right, I will have the generated form loading. So I can add a field to my inside of my form designer, decide that it will be a yes/no question, and I will call make a label which is, can I ask your name? And if I load this form, you will see that I have the can I ask your name field on the right side. But we can go further. We could add another field and choose input this time and choose the name as a label. And we can add some condition because inside of the domain, the form domains, we have a condition on them. What we do is we can select that this is displayed when this field is equal to yes. And now if I load my form, nothing happened, but if I click no, no field up is shown. If I click yes, then I have the name which is shown, and I can submit my form now. So we went from designing the written form using Fable.Form to JSON to map it to Fable.Form and let Fable.Form handle the new form again. And I have 1 minute left, which is what next. So the next step for Fable.Form will be to remove the Elmish dependencies because we only use it for the dispatch function, which could be replaced with a callback. And because Fable.Form is not tied to Fable, even besides the name, we can in theory use it on any .NET platform as long as we write the view layer for it. So I would like to explore this idea and also running it on the server side so you can have the same code between the client and server side and release the demo. And I think I'm just running out of time. So thank you for listening. You can find me on Twitter, GitHub, and Slack as this username, and on Mastodon with this other username.
All right.
Thank you. So if it's just
sorry, I rushed a bit at the end, sorry.
we've been just watching the YouTube discussion, which has derailed much further from the academic. This is more of a comment.
Yeah, but there were some jokes about if instead of JSON we can use YAML, but I think
you can use whatever you want.
Yeah.
As long as you want the serialization process.
CSV file. That's
Yes,
the data
yes.
format of the 21st century.
Yeah. If you want to make your life harder, yes, you can.
Yeah, let's make it more painful, right?
No, that doesn't sound like the right trend. No.
Okay.
All right. I think we are right about on time. So Maxim, thanks a lot. It was really a pleasure to see you again. Thanks for your amazing work, not only on this particular library, but I would say on overall Fable ecosystem, because as people already know that you are, I would say, responsible for more than one library, more than one amazing projects. So thanks a lot. Thanks for doing that. It helped a lot.
Welcome, and thanks for having me.